Finding horizontal and vertical asymptotes of a rational function. In the cases below, we're going to talk about a rational function that either has a quadratic numerator or a quadratic denominator. It's actually easier to find the vertical asymptotes because it's related to analyzing the domain of the function. Let's get started. First example A. We have a function where the numerator of the polynomial, the numerator is a polynomial of 7, and that degree is 0. Notice the degree of the polynomial in the denominator. That degree is 2. That's one of the first things you want to analyze of rational functions. Look at the degree of the numerator, which is 0, and look at the degree of the denominator, which is 2. Let's go ahead and find the vertical asymptote, and we'll come back to those degrees pretty soon. So finding the vertical asymptote is very similar to analyzing the domain. So if you're analyzing the domain, we want what? 2x squared plus 6x plus 4. We want that to never equal 0. Let's factor out a GCF of 2, and we have x squared plus 3x plus 2. React to this by factoring. I use trial and check. Make sure you put the appropriate signs and make sure you check. That does check when you multiply the quantity x plus 1 and the quantity x plus 2. You do in fact get x squared plus 3x plus 2. Now, getting the domain here says x plus 1 cannot equal 0. And we also know that x plus 2 cannot equal 0. So we know x cannot equal negative 1. And we know that x cannot equal negative 2. Now, we also know that this gives you sort of these lines or vertical lines that act as boundaries. And so what are the vertical asymptotes then? It's got to be x equals negative 1 and x equals negative 2. So just a recap on domain here, I could write the domain of the rational function in part A. It's not difficult. Negative infinity up to negative 2, union negative 2, comma negative 1, union negative 1 to infinity. So notice there's parentheses on the negative 2. Right next to the negative 2 there has to be parentheses, and right next to the negative 1 has to be parentheses because we do not include those x values. Okay. But at the same time, it will help you yield the vertical asymptotes. So that's part A. I'm going to make a little bit of room here. So I'm going to erase this. Erase the domain for part A. Oh, excuse me. I forgot to find the horizontal asymptotes in part A, so why don't we go back to that? Let's go back and analyze the degrees again. The degree of the numerator, the degree of the polynomial in the numerator is 0. If you're having a hard time seeing that, you could do a little bit of a little trick here. We could just write x to the 0, and now you can really see that the degree of 7 is 0. Remember, x to the 0 is just positive 1. Okay, what is the degree of the denominator? The degree of the denominator is 2. It's simply the highest exponent in your polynomial, so the degree of the denominator is 2. The degree of the numerator is less than the degree of the denominator. So if we wanted to name things, labeling is a mathematical skill, we could label p of x, the polynomial in the numerator is 7, and q of x is the 2x squared plus 6x plus 4. So what happened is we have a degree of p of x, which is the numerator, is 0, which is less than what? The degree of q of x. Let me go ahead and write the numbers. 0 is less than 2. Yeah. Which yields that the horizontal asymptote is simply y equals 0. AKA also known as the x-axis, right? So let's go ahead and circle that. And so we do have the horizontal asymptote as well. I'm going to try to scoot some of this work. See if I can here. Well, don't need to scoot it. Why don't I just draw a line? I could just move this one. How about that? Okay, and I'll draw a little bit of a line here so I separate my problems. There. Now we're done with part A. We found the vertical asymptote and the horizontal asymptote. Part B, once again, I'm going to take the approach of finding the vertical asymptotes. The way we do that is analyze the denominator. We want to make sure x squared minus 1 is not equal to 0. We could once again react to this. If you react to this, we get x plus 1 times the quantity x minus 1 is not equal to 0. X squared minus 1 is a difference of 2 squares. What does this mean? Oh, I think I forgot a 1 here. I need a 1 right there. That looks a little sloppy, so let's make ourselves look neater. Have an eraser handy. X cannot be what this time? X cannot be negative 1, x cannot be 1. So that will help you yield your vertical asymptotes as well. Vertical asymptotes then will be what? X is equal to negative 1, and x is equal to 1. So those are your vertical asymptotes. We have 2 of them. We need to find the horizontal asymptote. This time we're going to analyze the degree as well. The degree of the polynomial in the numerator is 2. Can you guys see that? Degree of the polynomial in the numerator. Why don't we call this one m of x, and let's call this one n of x. The degree of, well, why am I making this so hard? Why don't we call the numerator n of x? How about that? And the denominator, the name of the polynomial in the denominator is d of x. Degree of the numerator, n of x, is simply 2. The degree of the denominator is also 2. So we have the degree of the numerator is equal to the degree of the denominator. Now, what does that mean? That means our horizontal asymptote this time is the coefficients of x squared and x squared. So we take that highest degree and we look at its coefficients. I'm going to go up here. I'm up here now at the beginning. What are the coefficients of x squared and x squared? There's an invisible 1 here and an invisible 1 here. So the horizontal asymptote is really going to be y is equal to that invisible 1 over another invisible 1. And of course, you know, 1 over 1 is simply 1. So our horizontal asymptote is simply y equals 1. We could circle that. And there you go. We got vertical asymptotes and horizontal asymptotes for both examples.